Okay, so in class today you worked on solving the odd questions from this worksheet. So right now we're going to look at solving the even ones just to give you some extra practice. So here we have a compound inequality involving n, and we have two separate inequalities. So what we need to do is we need to solve the inequalities independent of each other. So we solve the first one, we can solve the second inequality. And then after we solve the inequalities, then we graph it. So I'm going to solve each inequality, and here I get n is greater than or equal to -9. So n is less than or equal to 4. Since it's less than or equal to, come up to the number line and we do a shaded in circle. And I know the arrow is going to go to the left. I'm not going to do it all the way until I test the other part of the inequality. So here we have n is greater than or equal to -9. So at -9, I shade it in. Greater than would go to the right. Since these arrows would be facing each other, the in between these endpoints is the solution. That's where they would overlap. If I drew this one that way and this one this way, we can see that that's the overlap. So the solution is, in fact, in between these 2 points. So we would just shade in between the 2 points. So you guys can solve these problems on your own first, and then watch the video clip of how to solve it to make sure that you solved it correctly. Here, we're dividing by a negative number. So whenever we divide an inequality by a negative number, we have to reverse the inequality sign. So don't forget to do that. So the second part here we're not dividing by a negative number, so we do not need to change the inequality sign. So we have our two parts. I'm going to graph this part first. P is greater than -6. So over here at -6, since it's greater than, it's an open circle. My arrow is going to go to the right for greater than. Okay. For P is less than or equal to 0. At 0, I'm going to do a closed circle because it's less than or equal to. And less than will go to the left. So we see the arrows are facing each other. We have an end statement. So both must be true. So we're going to plot the overlap. So to plot the overlap, you can just connect these 2 points here, and that would be the solution. We're going to solve each inequality separately. This one is a compound inequality with an or statement. So we have the quantity of x plus 1 is less than or equal to -9. So I need to isolate the variable x. I can subtract 1 from both sides of the equation. So now we have x is less than or equal to -10. If I wanted to graph that, I can come up here at -10, less than or equal to would be a solid circle, closed circle. Less than goes to the left, so I would draw the arrow and shade the number line to the left. Now I'm going to do the second part of this inequality, where we have x divided by 5 is greater than 1. So since x is being divided by 5, I need to multiply both sides of the inequality by 5. Here they cancel, so we have x is greater than 1 times 5, which is 5. So since this is an or statement, one of the inequalities or the other one needs to be true, so that we don't have to worry about the overlap. So in my number line, I'm going to go up to 5, which would be about here. Draw an open circle. X is greater than would go to the right. So I would shade the graph to the right. Okay, so for or statements, we don't have to worry about the overlap. It's one or the other needs to be true. Okay, so let's look at number 7. Again, we have an or statement. I'm going to solve first the leftmost inequality. So v plus 2 is less than -4. We can subtract 2 from both sides of the equation. This is the work that you need to show. So I have v is less than -6. So at -6, we would need an open circle. Less than is going to go to the left. So I would shade in the number line going to the left. For the second part of the inequality, I have v plus 5 is greater than 12. We'd subtract 5 from both sides, and we get v is greater than 7. So on go up to the number line, halfway between 6 and 8, we will put 7. It's an open circle. Since v is greater than 7, we're going to be shading to the right. Okay, so we're following the same process each time. We're solving the inequalities and then graphing the solution set. Now, for number 9, it doesn't have the words and or, but this is a compound inequality. Since it's written as one inequality, it would be an and inequality. And I can write it down. -56 is less than -8a, which is less than or equal to -32. Now this inequality has 3 parts. So what we can do is we can say, okay, I'm going to solve for all 3 parts. Since the variable term is being multiplied by -8, we can divide all 3 parts by -8. Since we're dividing by a negative number, we're going to have to remember to reverse the inequality sign. Okay, so when we divide, we reverse the inequality sign. We can do this part first. This is going to change direction, so it's going to go from less than to greater than. Okay, same thing over here. The less than or equal to, we're going to just change the direction, so now it's going to be greater than or equal to. So then -56 divided by -8 gives us a +7. -32 divided by -8 gives us a +4. And we want to now graph this compound inequality. So a is less than 7. I always want to read from the variable. A is less than 7. So over here at 7, I can do an open circle, and we want to go less than. And here we have a is greater than or equal to 4. So at 4, we have a closed circle. Greater than or equal to would go to the right. So these are going to overlap. So we can shade the solution set. Since they both have to be true, we would shade just in between the 2 points. For question 11, we have a compound inequality involving and. So we can break this up to 2 separate inequalities. So I can solve -4 is less than -9 minus 5n. And then solve that second part by rewriting the middle. -9 minus 5n is less than 36. And then solving each inequality separately. So here I'd have to add 9 to both sides of the inequality. So we have 5 is less than 9's cancel, -5n. Divide both sides by -5. Remember to switch the inequality sign, and we get that 1 is greater than n. On this side, we're going to do the same step, so I'm going to first add 9 to both sides of the inequality. -5n is less than 45. Now we divide both sides by -5. We have n, don't forget to reverse the inequality sign, is greater than -9. So we can graph each part here. N is less than 1. So over here at 1, I'm going to have an open circle. Less than will go to the left. N is greater than -9. So at -9, open circle would go to the right. These two are going in the same direction, so this will be the overlap in between our endpoints, which are open circles. They're open because 1 is not part of the solution set, because n has to be less than 1, not equal to 1. And -9 is not part of the solution set because n has to be greater than -9, not equal to -9. All right, so I'm going to look at question number 13. Number 13, we have an OR statement. We have 4a plus 4 is less than or equal to -24, and I can solve this first. I'm going to subtract 4 from each side, so we have 4a is less than or equal to -28. Divide both sides by 4. Since it's a positive 4, we don't have to worry about reversing the inequality sign. So we get a is less than or equal to 7. The other part of the inequality, we have 6a plus 3 is greater than or equal to 39. So we move our constant term first. I can subtract 3 from both sides. And then we divide by the coefficient of our variable. So we have a is greater than or equal to 6. So we have a is less than or equal to -7. So over here at -7, I'm going to need a closed circle. And it's going to go to the left because it's less than. A is greater than or equal to 6. So over here at 6, again, we want a closed circle. Greater than goes to the right. So we can draw it to the right. I hope you're finding these helpful, going over these problems for you, the ones that you were working on in class. All right, so now number 15. 15, I'm going to solve this one differently than I did the last one. Instead of breaking it into two parts, I'm going to just draw the lines down so I remember to solve each of these 3 parts instead of solving 2 separate inequalities. So to isolate the variable, I need to move this 2. Since the 2 is positive, I can subtract 2 from all 3 parts of this inequality. -7 minus 2 is -9. Bring down that inequality sign. Bring down the variable. Bring down the other inequality. -4 minus 2 is -6. This is a compound inequality involving end. So we have p, if I read it backwards, p is greater than -9. So at -9, we are going to do an open circle. P is greater than, so that needs to go to the right. Then we have p is less than -6. So an open circle at -6, and it goes to the left. We can shade the overlap, so in between the endpoints, and that would be our solution. Okay, question number 17. All right, so this looks like a pretty complicated problem. There looks like there's lots of things going on, but we're not going to let that intimidate us. I'm just going to rewrite the equation. 8x minus 6 is less than or equal to 9x minus 5, which is less than or equal to -5 plus 8x. I'm going to solve it just like I did the one above. I'm going to say, okay, we have 3 parts to this inequality, so let's solve each part. We want to isolate this variable term here in the middle, and that's where we want our variable, only there in the middle. Okay, so what we need to do first is combine our variable terms. So I'm going to subtract this 8x from all 3 parts. So it cancels over here, and I'm left with -6. Bring down the inequality. 9x minus 8x gives me x. Bring down the -5. Bring down the inequality. These cancel. Bring down the -5. Now, since we're isolating this middle variable, I need to add 5, but not only to the middle, I need to do it to the left and right sides. -6 plus 5 is -1. Bring down the inequality. Bring down the variable. Bring down your inequality. -5 plus 5 is 0. So now we have x is greater than or equal to -1 and x is less than or equal to 0. So at -1, we're going to draw that closed circle. Greater than is going to go to the right, and this is less than or equal to 0. So our solution is that right there. And finally, our last question. Question number 19. Okay, so for number 19, again, I'm going to rewrite the inequality. This time I'm going to write it as two separate inequalities because you can solve it either way, whichever way you are more comfortable. Okay, so first I'm going to solve this one. So I'm going to move my smaller variable term. I'm going to subtract 7n from both sides. Here they cancel. Okay, and I want to get this by itself, so I'm going to add 3 to both sides. Divide both sides by 2. And get 1 is less than or equal to n. On this one, I can subtract 8n from both sides. Here they cancel. I have n minus 3 is less than or equal to 3. So I'm going to add 3. Here we get n, the 3's cancel, is less than or equal to 6. So now I can write one inequality. 1 is less than or equal to n, which is less than or equal to 6. We can graph this inequality at 1. I'm going to do a closed circle. Since n is greater than 1, it goes to the right. At 6, we need another closed circle. N is less than or equal to 6, so it goes to the left. Where these two overlap, we can shade in between. And that would be the solution set. So I hope this video is helpful. If you have any more questions, please send me an email, tzuber@groverclevelandhs.org. Thank you so much. Let me know if there's anything else I can do for you to help you with this crazy year in algebra.